Yes, welcome to this session of Aspen hysy simulation. In this introduction cuts across for everybody, from the one who has never opened Aspen hysy to the one who knows something about it and needs to understand more about Aspen hysy. I have gathered some little information here that can help everyone and each of the person who is interested in knowing Aspen hysy. And at the end of this video, I expect someone to now come to the sense of understanding why he or she needs Aspen hysy, why he or she needs to have a knowledge of simulation. And at the end, I'll show you an example of a job that requires you to at least have some knowledge about simulation. And in general, as someone who has studied chemical engineering, you need to also at least know something to do with this, something to do with simulation, even if you may not go into it in your field, but you need to know something, because you never know in your next job interviews may be asked what simulation software or what computer skill about chemical engineering do you know. So that is it exactly. So here, what you see here is at the view how Aspen hysy looks like when you just open it, when you are there to start, when you are ready to start doing your simulation. Yeah, so my name is Herbert and welcome. Yeah, so in this one we want to know what is Aspen hysy. Aspen hysy is generally a chemical process simulator that helps simulating chemical processes and even physical processes as well. So why do we need the Aspen hysy? Aspen hysy generally, why it? So Aspen hysy generally does the following. It is a steady state and dynamic simulation tool. It does both to steady state and dynamic. And in steady state, that one you know well, according to your definitions that you know how to define steady state or even dynamic. So steady state does not involve time variable, and dynamic involves time variable. You can be able to understand the process, how it changes with reference to time. Then also it is a process simulator, like that's process and equipment design. You can design a process and the equipment at the same time. We shall give an example in the coming future on how to do that. Then also it does modeling, performance modeling, like you want to know the performance of your equipment, you want to know how your equipment behaves, and it also does optimization. So these are the general duties, or these are the general roles that are solved by Aspen hysy. So in this one, why do we need to learn process modeling? We need to learn process modeling because it makes work easier and faster. It makes work easier and faster. And also it can help you work on different real life scenarios. Maybe you want to see how the quality of the feed material, and you want to change the flow rate of that feed material because maybe the quality has changed. Maybe brew, for those who know distillation, ethanol distillation, you have your brew, maybe it is like it used to be 6%, and now in this batch you have 4%. What do you need to do? Are you still going to feed that same flow rate? What are you going to do to make sure you get the final product, which is at 96%? And also it can do multiple and simultaneous simulations. You can do very many things at the same time. You can be able to price and cost, do the pricing and costing of your plant. Now in Aspen hysy is called economic analysis, e.g. raw material, how much you need, the plant cost, and the utilities. Utilities like power, your water, etc. It can also help you to understand how the process behaves under different conditions, e.g. high or low pressure, humidity changes, or even in temperature changes. Now, Aspen hysy also is a very expensive software to use, but you can access a cracked version from getitopc.com. There you can download it. After downloading it, when you open it, it will ask you for a password. The password will be 123. After entering your extract, then you follow even the file that you download from there, the zipped file. When you open it, it even shows you the procedure of installing. You can install. These are the following people that you have a process engineer, simulation engineers, process design engineer, senior engineers, plant designers, and plant managers. But now here, you may ask yourself, what if I don't become any of these? There are scenarios whereby maybe you are in a plant and, like you said, you also go with the title of I studied chemical engineering. They can ask you, a problem can occur, then they say, we have a chemical engineer here. Let's hear what he or she is going to say about it. What can you do? Like, how are you going to help us solve this problem? Something can occur in your hands and you are the supervisor maybe of a certain section. What can you do to solve it? You have to actually make sure you practice. Like, you know something about this. Never know. Anything can happen from anywhere. So which companies do this? Which companies really need this? We have oil and gas. We have that sector right now starting here in Uganda. Maybe one of you can get into that, or maybe even not in Uganda. Maybe you can get a job from somewhere else. You can be able to apply your knowledge there. Petrochemicals, we have very many. We have many now in Uganda. Ethanol distilleries, also we have them here. Yeah, you can go and showcase your skills there. Sugar refineries, also there, because we have so many unit operations there that will need you to at least solve a problem at a certain point, even if you are not directly involved. We have plants, carbon dioxide, nitrogen and oxygen plants. We have food and beverages. Food and beverages, I mean, ham, Coca-Colas, and so on. Polymers, where they make pipes, taps, very many chairs. Where pharmaceuticals, painting and coatings, yeah, all those you'll use them there. Then also now we have what can you model? Because we said you can model a process, but what is it exactly? What do you need? So we have heat exchangers. You can model a heat exchanger. You can model a reactor. You can do pressure. You can model pressure change equipment, valves, pumps, compressors, distillation and absorption columns, extractors, flash systems, and separators and mixers. Yeah. So for here, these are the unit operations exactly that we can model. But then the combination of all these, if you know how to model one of these, you cannot fail to set up a huge process. You can be able to do anything about process modeling. A process simulation is just joining these equipment to make a process. A process where there's a reaction, where there's a heating, where there's a flow control, where there's increasing of pressure, reduction of pressure, Yeah, and all those you can be able to work on them. Yeah. So the next one is we want to know the benefits of process simulation. The benefits include the following. You can be able to determine the flow rates, stream flow rates, or other inputs, sort of operational and design issues. Yeah. Then also it can help you determine the stream compositions, can help you to control the physical properties like pressure, volumetric flow rate, and temperature. Also, you can be able to alter the unit operations conditions like power, temperature, pressure, and even the efficiency of the unit operation. Then we can help you also to do equipment design and sizing. Also, it helps you to improve a pilot plant and even test. If you're testing something on your plant, you don't need to stop the whole plant, then you disorganize it and start testing one by one. It can help you now to in exploring process technology. You have new technologies that come up, so you need to test them. So you first bring them to your software, test the behaviors of your system, the behaviors of the process in the system in your dry lab. Then from there you can transfer the knowledge, put it in the real system now. So the in engineering problems, you can do mass and energy balances. Now in your year 2, year 4, we have very many course units that have taught us a lot of these things, most especially CPP, CRIE, and food engineering. You find a lot of mass and energy balances. And remember, these softwares is where all the course is: thermodynamics, CPP, CRIE, food engineering, heat transfer, mass transfer, everything, all those principles, the equations involved are all in these softwares. So you don't need to ask yourself, why is it able to do this? Only what you need to know is all the equations that you may think, that you might have seen in your studying, in your course units, they are all here. Even some that I have not seen, they are all there. They did all the programming, they changed all those equations into a software. That's why it is able to do mass and energy balances without you seeing it solving, but all the concept is there. It's just you to feed in the required information and it gives you the answer. We shall see an example of a mass and energy balance problem that we can solve from here. We can pick it from anywhere, put it in the software, and we solve. Also, it can help you solve the transport phenomena problems like heat, mass, and momentum. Equilibrium relationships like Gibbs energy and entropy, that one, the one you find in thermodynamics. Then also personally, you need to have, it will help you improve your analytical and numerical mind. And also as well as your CV. When you put it in a CV in a job that requires a chemical engineer, put it in your CV, you'll be among the people who will be considered. Next, so in this one, I try to look at to extract some job requirement that was advertised at PAU, Petroleum Authority of Uganda. Here they needed a process engineer. The job summary: the process engineer will follow up and participate in the monitoring regulation of process engineering aspects of oil and gas processing facilities, including the assessment of design, optimization, installation, and maintenance, daily operations and commissioning. He or she will be able to report to the operations engineer. But now let's look at the requirements from this side. You need a bachelor's degree honors in chemical and process engineering or industrial chemistry. Experience, yeah, so these things we cannot learn them once, but as time goes, you can learn the software slowly. As time goes, you can meet something like this, and when they call you for interview, at least you should be able to defend yourself. Yeah. So 3 years experience, start from nowhere, and yeah, you can be able to develop the experience from there. Then also they need a master's degree in process and chemical engineering, ability to interpret and analyze process diagrams, excellent interpersonal and communication skills. Then you need proficiency in using of relevant process simulation software. This area here, proficiency in using relevant process simulation software. Then also excellent in analytical critical thinking skills, proven records of outstanding performance. All these are things that come in from your input. Now the energy you put in learning, yeah, that's when you'll be able to showcase your skills, analytical skills and critical thinking skills. Yeah, that's all. So now in the next we shall be now going to direct the software itself. We shall be explaining everything from start up to when we shall be able to do most of the process unit operations. We shall be doing them one by one. Then at the end we shall have assignments to do. We can pick any from anywhere. We can go to our books that are existing. Then also after studying all the unit operations, simulate a process itself. We shall start from simple to least simple, then to complex as time goes. Yeah, thank you, members.